In the previous class, what we saw? Differential calculus. Okay, we saw the differential calculus, we saw the derivative, differentiation of a function. Okay, and then we found out some properties of the differentiation also we saw, and the differentiation of some functions also we saw. Okay, so what we have is, suppose for example, what is the differentiation we have? If you have a curve, so at certain x, so what's the derivative? Derivative is nothing but the slope of the tangent line to that point, right? This is what we call as df by dx. And we did some problems also. You remember? So for example, suppose if you have f of x equal to x power n, we know that formula, right? So df by dx. So what we have, df by dx will be equal to n into x power n minus 1. So now you see this one. So if you see carefully, this is also a function of x. Am I right? This also depend upon x. So let us, if I write that as g of x. So then what happened? I can write it as df by dx will be equal to g of x. Correct? You understand? So you can take any function. Let us take this function. F of x equal to sin x. What is df by dx? We saw. Cos x. Okay. This is also a function of x. I can write it as, may not be f of x, maybe some different function of x. So df by dx will be equal to g of x. That can be another function of x. Okay, so here what happened? So this is, so now the question is, so now I give you g of x. What is that? I give you g of x. And if I ask you, can you find out what is the f of x? You understand? That means I am giving you this value and I am asking you, this is a g of x. I am asking, can you find out what is f of x? You know, x power n, inverting it, right? If I give you cos x, can you find out that is g of x? Can you find out what is f of x? That is sin x. Okay, so that inverting, you give means how to get the function back. Okay, that is what you call as an antiderivative. Okay, so antiderivative. So what it says is, so we are having df by dx. Okay, suppose df by dx gave us to gx. I am asking, so what is, if I give you g of x, what will be my f of x? Okay, that means here, if I give you g of x, what is your f of x? F of x power n. If I give you g of x, cos x, what is your f of x? That's sin x, right? Or other hand, in a way how they write this is, so f of x, if this is what you call, f of x will be antiderivative of g of x. Correct? You got it? So you basically kind of an inverse of it. Reverse of the derivative. So this antiderivative is called as your integration. And the symbol is like this. Okay, so what it says is, so from here your f of x will be integration of g of x over dx. Okay, so this is the representation of your integration. Okay, so this is what you call as integration. Okay, so when you see it from the plot, what it says is, so df by dx is nothing but the slope of the tangent drawn at x. Correct? So now the question I am asking is, so if I give you this tangent, slope of the tangent drawn at x, what should be your function f of x? You got what I am saying? So this is what? This is a function f of x. Right? So I'm inverting the problem. So what happens? So first we given f of x, we got df by dx. That is the slope of the tangent drawn at x. Now I'm giving you this. Can you get back this? So this is differentiation. And this is your integration. Okay? So this is what? That's why we call it antiderivative. Okay, reversing it. That's what I have done here. Given a function f of x, you know the derivative of f of x, you have all the formulas. So that will give you some function, next I am calling it as g of x. Now I am going to give you g of x. And asking you, can you find out what's my f of x? So that means what? I know this is a g of x. I'm giving you g of x. You want to find what is f of x. That means kind of an antiderivative. Am I right? So what am I going to do? So f of x will be antiderivative g of x. I'm going to write as g of x is a symbol. Okay. So this is what your integration is all about. Okay. And in an easy way to understand is, okay. So this is what we, when you, so this is what you call as a integral or integration, and this is what we call as a indefinite integral. I'll come to that. Okay. So what we have, df by dx, if this is equal to g of x, what we said is, and then f of x, that's a antiderivative of g of x, that we wrote it as what? Integration of g of x dx. Now, and I told you, okay, so what is that? This gives you, so if this is the g of x is the slope of the tangent drawn at a point x, and from there how will you get back the curve? Okay, so what, let us physically try to see what this means. Okay, it's a theorem, you will prove it in your 12th standard probably. Okay, so that you will see that. There are some theorem also which is what you call as your fundamental theorem of calculus. Okay, so that probably you will do it in your 12th standard. Okay, mathematics. So for timing, let us take up in a very quickly we do this one. Okay, so what is the physical picture of this integration? I'm going to forget this one. Integration of g of x dx means what? Let us try to understand it. Okay, so you got it. So what we have, so we are in g of x. What do you mean by physical picture of integration of g of x dx? Okay, so how to understand the physical picture is, so let us, I am giving you a straight line. So let it be f of x. F of x is a straight line here. Okay, so it's not a curve. F of x. And I am giving 2 points here. Let us take 2 points. A, B. So what will be this point? F of A, and this will be f of B. I'm asking you, what is the area under this curve, under this line, bounded by A and B? Below this line, bounded by A and B. So what you can do, we can divide it into 2 parts. This is the area of the rectangle and plus area of this triangle. Okay. So what is the area of this rectangle? Tell me. Area 1 I will call. So it's a
B minus A.
Yeah, this is the breadth B minus A into the height is f of A. So what is the area of this triangle? Half area 2 I am writing. Okay. That will be what? Half into base. Base is B minus A into height will be
F of B minus F of A.
Yeah, f of B minus f of A. So therefore, the total area we can write it as equal to f of A into B minus A plus half into say B minus A into f of B minus f of A. Okay. So what is the area of this rectangle? Half area 2 I am writing. Okay. That will be what? Half into base. Base is B minus A into height will be f of B minus f of A. Okay. So now let us consider different. So this is not going to be a straight line. I am going to give you a curve. Okay, not a straight line. It's going to be a curve. Then you can't use this simple way of finding the area of the rectangle and the triangle. Okay, let me. So what you are going to give is, I am going to give a curve which is not going to be a straight line, maybe say something like this. And I am going to call it as a g of x. Okay, I am writing g of x so that you can compare with this one. So I am going to write it as a g of x. And I will now, let us take again the two bounding points. A, so B. Okay, I shouldn't use f of x, always don't, whatever I mean, I should use f of x, g of x only here. This is what we are doing, right? We want to understand what it means. Okay. So, okay, so now you tell me, I want to find out the area under the curve. So here you can't, this is not be a triangle. Okay, so the way how I can find out the area, this curve can be any or be something like this also, maybe a curve also. Okay, what I'm saying is it can go something like, instead of this, the curve may look like, it may go something like this. It can be any curve. You understood, na? It can be any curve. So we don't know. So we can't use that earlier technique of finding the triangle and all. So how to find out the area of this region is, let me divide this region into small segments. Okay, and then I will find the area of these rectangles, small rectangles. Okay, so what am I going to do? Instead of A and B, I will write it as, let me write these points as x0, x1, x2 up to say something like xn I am dividing. So each of this division will be x0 minus x1, x1 minus x2. That's a gap, correct? So I am going to call this gap as, say something, I will call this gap as, I will not take 0. In your book, they don't have from 0. Okay, so let me find x1, x2, x3 and xn. So this first difference, x2 minus x1, I will call it as delta x1. x3 minus x2, I will call it as delta x2. So say something, for example, I am going to give us, so I go on like this, so some xi I will approach. Okay, and then this is xi. The corresponding width will be delta xi. That is equal to xi plus 1 minus xi. Right? So now I am asking you, so what is so this is xi and this is, so what is the area of this small segment? Can you tell me?
Delta xi.
Correct. So this is xi. Am I right? So if this is xi, so where I am here, yeah, this is xi. So that means this point, right? So this will be what? This height will be g of xi. Correct? Because the g of x. G of xi. So you know. So the length is g of xi into the breadth is delta xi. So the area of this small element. So let me write out the area of this small element as delta area of some ith element, right? Ith element will be what? Tell me. F of x, sorry.
No, G.
G of xi. Tell me g of xi into delta xi. So now I want to find out the area of the whole region from x1 to xn. What it will be? Tell me the total area will be, you have to add up all the elements. That means what? Summation of I, right? I from I equal to 1 to I have to up to n, right? N times of delta area of I, right? So all the elements I add up. So that will be what? Tell me. Summation of I equal to 1 to n, delta of I equal to g of xi into delta xi. Okay. So now, if you wanted to get this area more and more accurate, because you know this is not accurate, am I right? When I put a delta xi, you are having some portions are missing. That is here. These portions are missing. Am I right? Suppose if I wanted to get it more and more accurate, what will I do? I will divide it to the large number. 50, 100, 200, 1000. I'll keep dividing it, right? Suppose if I want to get more accurate, I'll keep on increasing the number. As I keep on increasing the number, what will be delta xi will become? Reducing smaller and smaller. Suppose if I make it delta xi approaches 0, so then what it becomes? Infinitesimal. So I have, suppose if delta xi becomes smaller and smaller and smaller, finally if it becomes approaches 0, what we are going to get is the infinitesimal. So to get an infinitesimal, what is the number you should have divided? Infinity. So if this region, if you divide by infinity times, then this region will become infinitesimal. Okay. So if I divide this n, if the n goes to infinity, then delta xi will become dxi. Okay. So then what I will write is, so this we can, so the accurate area will be, let me write it here. So the accurate area will be limit of n tends to infinity, summation of I equal to 1 to n g of xi delta xi. Okay, so when n tends to infinity, your delta xi will become dxi, correct? So you can write this as, so g of xi, when n tends to infinity, delta xi will become dxi. Okay, and the summation, you don't write it as summation, you write it as integration, this symbol. Okay, and you are not adding all over the space, you are adding from x1 to xn, correct? That's what means I equal to 1 to n. So this will be x1 to xn. Otherwise you can write it also, oh sorry, this will be x, not xi. Okay? So this is how we write it. So g of x is a function. So g of x dx. So take any x and into the dx. So this is going to be the area of the smaller element. Am I right? G of x dx. G of x dx. G of x may be at some point value small dx. Small element. And when you integrate, when you add up those elements from xn to x1 to xn, that gives a total area under the curve. And that's what your physical meaning of your integration is. Okay. So you will, this is what. So, and now we can see, therefore you are getting two types of integrations. One integration is without any limit. That is what? G of x dx. Okay. So this integration is called as indefinite. And this is called as your definite integral. Okay. So this is what you will, this is all you have to see it for in your Fourier physics class. More about this integration and all you will study in your 12th standard mathematics. Okay, so there's a chapters on this indefinite integrals and indefinite integrals. You will see about that more. Okay, I want to tell you one more thing. Suppose, so fine, so we saw that. Okay, so integration of g of x equal to f of x, for example. So then I'm trying to take the same analogy here. Okay, so then what this will be, so that also comes from the fundamental theorem of calculus, probably that you will study in your 12th standard. Okay, so now I said integration of g of x equal to f of x. So integration of g of x, x1 to xn, this will be equal to, okay, f of xn, there's an upper limit. We call it the limits of the integration. Okay, x1 to xn. So f of xn minus f of x1. This is the way integration is doing, different integral calculation will be done. Okay, so this is what. So this is all about the integral calculus. So let us take some examples. Okay, so I can tell you something more interesting with this one also. When you compare this derivative and taking the pictures of derivative and antiderivative. If you remember in the earlier class, what I said is, so we will take up two cases, simple two cases. So, okay, what we had, if you remember, d by dx of some constant a will be equal to what?
D of A by dx.
A is the constant.
Constant, right? 0, 0, 0.
Correct, 0. Okay. And tell me d by dx of, tell me what?
Cos x
Cos x. Oh, okay. Cos x will be equal to
minus sin x.
minus sin x. Or don't take minus, but you are unnecessarily complicating with the minus. That also you can do. Sin x will be equal to cos x. Okay. So now what I said, integration is the antiderivative. So if I take an antiderivative of cos x, so what is the antiderivative of cos x? Cos x dx should be equal to sin x. Okay. So what it says, integration of cos x dx equal to sin x. This is not completely correct. The reason is, let me call this as 1 and this as 2. Okay, let me add up 1 plus 2. Okay, so 1 plus 2 is what? D by dx of some constant a plus d by dx of sin of x will be equal to cos of x. Okay, now you remember, if you remember, we had one property, f1 of x, f2 of x, correct? So d by dx of f1 of x plus f2 of x will be equal to df1 by dx plus df2 by dx. So this can be written as d by dx of these two functions, a plus sin x will be equal to cos x. Now tell me the antiderivative. So if I do the integration, take the antiderivative of it, what happens? Antiderivative is cos x dx. Will it be equal to sin x?
No, A plus sin x.
Okay, and this is always an important property because so whenever you are integrating a function, so therefore what happened? So if you are having when you are integrating a function, you will always get on. You should always remember. You should always there's a one constant term which can be there, which may be 0, may not be 0, but your derivative will always takes at 0. Okay, so what happens? So if you this one, so the why I said is, so when we do this integration, g of x dx, this is not just f of x, it will be f of x plus some constant term always. Okay, so and you will see when you have a definite integral, this constant term automatically cancels. So when it becomes definite integral, this will be this one. You don't have the constant term. Okay, when you have an indefinite integral, this constant term should always be there. Anyway, you will read more about it in your 12th standard. Okay? Cool. You understood the reason, right? Why we have that. No. Okay, so now let us do some more. Okay, so this is how your integration is being done. So let us do some properties of this integration. Okay, they are given only two properties, so it doesn't matter. So simple properties they are given. The same thing like you have two functions, f1 and f2. Okay, so now hereafter I will not write it as g, I will write it as f. But don't confuse this f and that f. Okay, because I am going to use some functions. You see, I wrote it sin x, cos x. If I can write cos x as f of x, and this is g of x. So let us take two functions, because usually for functions they start with a f. In your book also they written f. So you should not confuse with your other one. Okay. So now let me give two functions. Any functions f1 of x and f2 of x. So I want to integrate the sum of these two functions. That's what integration of f1 of x plus f2 of x dx. dx. This is equal to f1 of x dx plus f2 of x dx. Okay, remember this property. Another property is very simple. You multiply any integration with a constant. So if you have k into f of x dx, you can take the constant where k is some constant. K can be taken out of the integration. So what I am saying is, in the place of g of x, if you have some a into g of x dx, this will be nothing but a times g of x dx, or therefore the formula will become a times f of x plus c.
It's the same. It's like similar to that one. It's the derivative.
Exactly. Okay, the same in the derivative we have. Exactly the same. These are the only two properties they have, and yeah, and then see this can be actually proved very easily. So if you know that, as since I said, integration is nothing but an antiderivative, you can actually find out. See, if you remember, we had one derivative here, right? D by dx of x power n will be equal to n into x power n minus 1, correct? Let us take the antiderivative. So, if I want to take the antiderivative, what it says, x power n will be integration of n into x power n minus 1 dx, correct? So, now what am I going to write? Okay, so is a constant, am I right? You can take it outside. So, what this will become? N into x power n minus 1 dx. Right? So, this will be equal to x of n. So, now I don't want x of n minus 1. I want to use some, I am putting a term m equal to n minus 1. So, therefore, n will be what? M plus 1. Okay. So, therefore, and then n will be? That's what you wrote. Nah, correct. Sorry, yeah, I didn't realize that you wrote that. Okay, so now so this will become what? X power n. X power n is what?
X power n plus 1.
M plus 1 will be equal to n is what? M plus 1 into integration of x power m dx. So, what it says is, if I give you, so from here, integration of x power m dx will be equal to what? M plus 1 divided by m plus 1. You got the formula for? Okay, so this is what? So if you have d by dx x of n, x power n equal to n into x power n minus 1, therefore, let me put it in different color. So since this is the formula, your antiderivative, integration of x power n dx, the same thing I am writing, will be?
X into n plus 1.
Correct. X to the power of n plus 1 divided by n plus 1. Okay. So this is what. So similarly, we can go for the next one. You remember we did the log of x also. We had d by dx of ln of x, natural log. You remember? That will be equal to 1 by x. So you tell me the other one, antiderivative of it.
So 1 by x equal to?
Correct. dx by x or 1 by x dx, whatever the way, will be equal to ln of x. Okay. Now let me write the other one. What you had? dy by dx of exponential. Euler's number, you remember? Either e of x will be equal to e of x. Correct? So this will be what? Tell me.
E of x equal to the integration of e of
Correct? You remember the one more thing we did, e power ax. Okay, tell me what should be. D by dx of e power ax. What we get? A into e power ax. Right? So now you tell me here what this will be.
So
This is simple, na?
a times integration of e power ax dx.
E power a times.
You can take outside.
Correct. A to take this side, na? So a power ax dx will be.
E power ax divided by e.
That's it. You understand? All these properties we can actually prove. Anyway, e power ax, they don't have it. Don't worry about it. So they are not in your book, but still you can do it. Okay. And then we do all the trigonometric functions we can do. So let us, for example, simply take the sin x and cos x that we already done here, right? So d by dx of sin x will be equal to cos x. D by dx of tan x. Oh, sorry, cos x. Tan x, and we don't have to do it. Okay, that anyway you can pick up and do it. Anyway, you don't have it. Cos x will be equal to minus sin x. Now, can you tell me the
Sin x equal to integration of cos x dx.
correct? So integration of cos x dx will be equal to sin x. And tell me.
Integration of we can take minus outside.
Yes, sin x
Sin
dx.
dx equal to negative cos x.
Yes, you understand? So the sign you have to be always cautious. Sign reverses. Integration of sin x equal to minus cos x. Differentiation of sin equal to cos x. You see this one, these two. So these are the basically two things, right? Differentiation of sin x, integration of sin x. Differentiation of cos x, integration of cos x. Okay, so only the sign reverses. You got it? So this is the way we can actually get all the derivatives. They given some problem. Let me do one problem and we will stop it. Okay? So the problems are simple. The same way, similar to your differentiation. So they given, evaluate. Oops, I can't see the number. I don't know. Can you read this? What's the evaluate? X power 8, I think so.
X power 8 dx. Integration of x power 8 dx.
Yeah. Give me.
It should be with the first formula we can.
Correct. Okay. So this will be what?
X power 9 by 9.
In your book also they give this is the answer. But this is not correct answer. To be the correct answer, we should always write plus constant. I told you, right? Always integration should be plus constant. You should have. Okay. That's simple because but in your book they are not given, it's okay. So then another question they have is, okay, integration of 5 to 2. This is an indefinite integral. They gave another integral, that is, what is that they have? 2 to 5 x square dx. Okay, I forgot to write the symbol form. What you have is, okay, so I wrote it, right? F of a to b. Okay, so the way they write it is something like this. I said that. So what you had is, if you remember, a to b, g of x dx will be f of x a to b, that equal to f of b minus f of a. Okay, I wrote this, I didn't write like this, right? Okay, yeah. So you have to basically do the integration and then apply the limits. Okay, yeah. So then what happened? You tell me first do the integration. So what is x square dx? Anyway, I removed it.
X cube by.
Yes, correct. So what was? I removed this one. X power n dx will be equal to x power n plus 1. Fine. So this will be what? Tell me.
X cube by 3.
X cube by 3 in the limits 2 to 5. It doesn't need constants, remember. Whenever it's a definite integral, you don't need a constant. Okay, this all probably will prove it in your 12th standard. So tell me what it is. So now, so this is what, right? So first, suppose what I wrote, f of b minus f of a. So in the place of x, you have to write the b value, right? So it's what? 5 cube by 3 minus 2 cube by 3. You understood? Where the place of x, you just substitute your limits. So then I can take this 1 by 3 commonly outside. We'll have 5 cube is what?
125 minus
125.
8.
8. So how much it will be?
1 by 3 is 1, 1, 7. 170.
You can divide it.
You can divide it 30, 39.
3, 9. Yeah. In your book, they have not even divided it. Okay. So you can do it. So this is another problem. And okay, they give one more problem also. With that, I will stop. Okay, the last one. Sub problem. This is. So that's what? X plus, okay, that's again your indefinite integral. X plus sin x dx. X plus sin x dx. So what it will be? I saw you can use a property. f1 plus f2 means integration of x dx plus integration of sin x dx. Suppose if you have a limit, the same limit will come here. Okay. So if there is some 1 to 2 or something else, 1 to 2, 1 to 2. Here they don't give it. So what will be?
X square by 2.
Square by 2.
Plus minus square.
Correct? That's it. Wait. In the book they have written it wrong. X square by 2 plus cos x. No, it's minus cos x. Okay. Your sin x dx, integration of sin x dx equal to minus cos x. So x, so it's you have to correct it in the book. Okay. So with that, I will stop this second chapter on mathematical methods. So what we saw vectors and calculus. In the calculus, we saw the differential calculus and the integral calculus. These things will be used in our later on chapters. Okay.